In this video, I'm going to walk you through a GED math study guide and practice test questions to help you pass and move ahead this year onto bigger and better things like college or a better job. And if you're new to my channel, my name is Parker and I really appreciate you being here. We just had a baby recently, so I haven't had that much time to make long videos in a while, so I wanted to put together a study guide series for GED math. And I want you to know here that I plan to have this study guide series done in this video and just one more video after this. But if the videos just get way too long, I might have to do it. I might have to make a third video, but I'm planning to have it done in 2 videos here, and I'd like to have the second video in the series done and put out within the next week or next 2 weeks. But like I said, we just had a baby, so my schedule's a little crazy right now. So unfortunately, I can't promise that. And I also want to point out here that we're going to cover a lot of things in this video and the second video. And if you understand everything in this video and the second video, then you should know enough to pass the GED for sure. I mean, the potential to pass just based off of these 2 videos, if you understand everything, it's definitely going to be there. But, you know, that being said, I can't guarantee that you're going to be able to pass just from these 2 videos alone. It's up to you to decide if you need more practice, and many people will need more practice than just what you can get in these 2 videos. It's always a good idea to learn as much as you can, and it can't hurt to do more. But just know that the potential to pass is definitely there if you really understand everything. Now, if you're trying to get like a college ready plus credit score or like a really, really high score like that, then you're going to have to do some additional studying outside of what you're going to get in these 2 videos for sure. And I'm going to point out some things that you should study in addition to what you learn in these 2 videos for a very high score as we go. But just know here that if you want more insurance that you know enough to pass, it's only going to help you to do more practice. If you're looking for the second video, whenever I have it done, I'm going to put a link to it at the top of the description or near the top of the description below. So you can look for that link when you're ready to move on. And also just know that, you know, I like to explain things in a lot of detail. Some people don't like that necessarily, so you're free to decide how you want to use this video. You're more than welcome to skip around. If you feel like I'm talking too much in the intro already, you're welcome to skip ahead to the problems. And as I go throughout the problems, I try to be very thorough and explain things, you know, in detail. And not everybody likes that. Some people just kind of want to see the answer and just want to get the bigger picture and then move on to the next question. So you're free to skip around as much as you like throughout the video. But that being said, we're going to start with some basic fundamental things that you need to know about the math section. Then shortly here, we're going to get into the actual practice problems. But first, you want to know that there's going to be 115 minutes given to you to take the test. And the study guide says that, from the testing service, says that you'll have a 3-minute break in between the parts to retrieve your calculator. Now, you should know about that there's 2 parts on the test. The first part you are going to have to do without a calculator, but it's not going to be most of the questions on the test. For the majority of the test, you will be able to use your calculator. And I've heard that if you're taking the test online right now, you're not allowed to use your own calculator. You have to use one that they give you on the screen. So that might change though, because they do revise those online testing policies from time to time. So you'll want to check in your area and based on when you're taking the test or watching this video. But if you're testing in person, you should be able to use your own calculator, but it has to be that specific type of calculator for the test, which I've talked about in other videos. It can't just be any calculator. I think it's called the TI-30XS Multi-View Scientific Calculator is the kind that you can use. But just know here that the test, it's going to be about 46 questions long. And I say about because sometimes they'll give you 44, sometimes maybe 47 or 48. But for the majority of cases, you're going to have 46 questions or about that, give or take. And assuming you get 46 questions like most people will, and you have 115 minutes to do it, that comes out to about 2.5 minutes for each question to help you kind of have a rule of thumb here for budgeting your time. And some questions, if you're studied and you prepared, which I'm sure you will, you know, it might take you 30 seconds or a minute to answer certain questions only. You won't need 2.5 minutes. And then on other questions, if they're harder, maybe you're going to take 4 or 5 minutes or longer to answer them. So, you know, just know though that as a good rule of thumb, 2.5 minutes per each question is the most you'll want to allocate when you're allocating your time on the test. Now, as a general rule of thumb for time management on the test, I wouldn't recommend spending too much time on any one question. Never leave anything blank. Always just put a guess. If it's a question you just have no clue about, just definitely guess on that question. Don't leave it blank. And you can use the mark feature to mark that question, then move on to the harder questions, and then circle back to move on to other questions on the test that are a little easier. Then at the end, with whatever time you have, you can circle back to the harder questions that you marked and take all the time you need to on those. But the thing is that I've heard some people say there's kind of like a pattern where the test starts off with a few easy questions, and then the questions in the middle are really hard, and it kind of throws you off. And then at the end of the test, they put some more easy questions there. And so a lot of people, they spend too much time on the hard questions in the middle, and they get to the easier ones near the end, and then they don't have enough time to do them. Now, I can't confirm. That's kind of a rumor that I've heard from a lot of students say that. The GED testing service has never confirmed or denied that, but just don't be thrown off if you get, several or many hard questions in a row in the middle of the test. You might get some easier ones near the end, so you don't want to spend all your time just trying to figure out the harder questions, because the easier questions that you can get right are also going to really help your score. So just keep that in mind. There's going to be a mix of easy, hard, and medium difficult questions. And if you've prepared well, it is still normal to get questions that are going to stump you. It's probably going to happen from time to time. But just know here that you'll get a mix of difficulty throughout the test. So don't be scared if you're getting a bunch of questions that you're not sure how to do. I've also heard a lot of students say that while they were taking the test, they were sure they were going to fail it. They were just thinking to themselves, "There's no way I'm gonna be able to pass this," and then they still passed. So I can't guarantee that'll be your experience, but just during the test, try to just keep telling yourself that you just take one question at a time. If you have 10 hard questions in a row that stump you, the 11th question, just try to look at that as a new question and a new chance to get some more points for your score. And just a general tip here too. If you didn't study a topic, it might be a good idea to just guess on it and mark the question and then come back to it later. That's, of course, up to you to decide if that'll work for you or not. But what I mean is, let's say you've never practiced triangles or not. You've never done any practice with triangles. If you get a question with triangles, right, it's probably, might be a good idea to just guess on that one and then at the end come back and try to figure it out. If you know you haven't studied it, then, it might be better to spend more time on the stuff that you have studied when you see those kinds of questions on the test. But again, up to you to decide how you want to spend your time. Now, I already mentioned this. There's two parts. There's a calculator part. Calculator is going to be allowed for the second part of the test, which will be the majority of the test. You're going to be able to use a calculator on the computer regardless of whether you buy one or not. And you'll also have a reference sheet that you can use that's going to calculate a reference sheet. Another good idea is to try to kind of practice or at least familiarize yourself with how the calculator is going to work before you take the test, so you don't have to kind of figure it out based off of the reference sheet. And they'll give you a math formula sheet. And so generally speaking, there's really not much to memorize for the math section. I'll point out a couple things that would be good to memorize throughout this video, but there's not a ton of memorization. It's mainly just problem solving, critical thinking type of stuff. All right, so now, like I said, at any time, you're free to skip around on the video, but I'm going to show you, really give you kind of a checklist here of things that you should know for the GED test. And it's not my checklist. This is coming from the GED official study guide. And for each of these topics here, we're going to cover one example that the example is provided to you by the GED testing service. I'm just going to explain it and break it down. They just give you the answers on their study guide. They don't show you how to do the questions. That's what we're going to do in this video. But just know here that, this is for people that want to see what we're going to learn in this video. And also if you want to kind of make yourself a little checklist of topics. And this is only going to cover probably half of what you need to know here in this video. Like I said, there's going to be a part 2 here, so stick around here. But the first topic they mentioned on their study guide is fractions and decimals and how to put them in order. So you'll want to know how to do that for sure. And you also want to know about multiples and factors. You'll want to find multiples and factors. And for example, the least common multiple of 3 and 5 is 15. The greatest common factor of 12 and 30 is 6. And we're going to look at an example of how to do one of these things later on in the video, but just know that, this is a topic that if that example doesn't really drive it home for you, you might want to study it a little more in depth. Another skill you'll need is to simplify exponents. And it says here, simplify numerical expressions with exponents. And for all of these major skills, we're going to look at one example, like I just said. But I have several videos on exponent rules too, so if you need more practice, I've got a lot of videos on that. Another skill is the distance between numbers on a number line. It says here you'll need to be able to know how to find the distance between numbers on a number line using absolute value. The next thing it says you'll need to know is whole numbers, fractions, and decimal problems. It says compute and solve problems with whole numbers, fractions, and decimals. And like I said, we're going to look at one example of how to do this skill, but we're not, in this video, we're not going to be able to look at every single case that could possibly come up when it comes with whole numbers, fractions, and decimals. We're going to look at one key example, but just know that this is a topic to master for the test. Now here's another thing. It says squares, square roots, cubes, and cube roots. It says that you'll want to be able to calculate and compute with squares, square roots, cubes, and cube roots of numbers. Now in this video, we're going to look at an addition problem that has to do with adding square roots and how to do that. But we're not going to really talk much about cube roots or really cubes and that kind of thing. So if you're aiming for that really high score, or you just want more insurance that you're going to be able to pass, you'll want to do some additional practice probably with squares and cubes and cube roots. Just something to keep in mind. Another thing you'll want to know how to do is how to deal with undefined expressions. You'll need to know that expressions with a denominator of 0 are undefined and have no solution. So basically, I'll mention this later in the video, you just need to understand those two cases when something is undefined, if the denominator has a 0 in it, or if there is a negative number under a square root. And if that sounds like I'm speaking a foreign language to you, don't worry, we're going to break it down in an example later on in the video. And you'll also need to know how to find unit rates. You'll need to do things like understanding miles per hour, dollars per pound, that type of thing. And also you'll want to know how to work with objects at scale. Like it says, you'll need to know how to use scale factors to convert dimensions between scale drawings and actual objects. And I know a lot of this stuff just kind of sounds like I'm speaking gibberish, but once you see an example of this, I think it'll help you understand what you have to do. Now, the study guide says here, for example, you might be presented with an image of the dimensions of a room. The image may use 1 inch to represent 1 foot of real space in the room. So just keep that in mind. Now you'll also want to have practice with multi-step problems that use ratios, proportions, and percents. And it says you'll need to be able to solve multiple multi-step problems that use ratios, proportions, percentages. It says examples could be simple interest, percent increase and decrease, gratuities and commissions. And we are going to look at a key example that deals with these skills here. But if you're looking for that really high score, you'll want to make sure you know how to do simple interest. For sure. Gratuities, that's just kind of like tipping at a restaurant, like how much, would the person tip if they want to give a 20% tip, commissions, that kind of thing, like, sales tax is another thing that falls under this, these types of questions. These are kind of word problems typically, but percent increase and decrease and simple interest are two things you might want to look at separately. And ratios, proportions, and percents are, there's all kinds of different types of questions and variations of types of problems you might get on ratios, proportions, and percents. We'll cover the basics here in this video, but that's something that you might want to do some additional practice on as well. Now also it says side lengths of shapes when given the area or perimeter. So it says find the side lengths of triangles, rectangles, and polygons when given the area or perimeter. It says remember you'll be provided with math formulas on the test. Now we are going to look at rectangles here. Squares are basically the same process here. And triangles, we're going to look at some triangle stuff later in the video as well. Not necessarily finding, actually we do have one where we kind of look at side lengths and stuff like that. But I think triangle area calculations and stuff like that, I don't think it's that complicated. But just keep in mind you'll want to be able to do that. Now it says here area and perimeter of 2D shapes. It says find the area and perimeter of two-dimensional shapes including triangles, rectangles, polygons, and composite shapes. It says again, you'll be provided with math formulas. Now it goes on to say area, circumference, radius, and diameter of a circle. It says find the area and circumference of a circle. Find the radius or diameter of a circle when given the area of circumference. Now I do believe that the question that we're going to look at with circles, plus I add some additional notes later on in the video to this. For the most part, I think that after this video you should be prepared for, I would wager 90–98% of circle questions if you understand the example in this video as well as the additional note or two I make here. Probably the hardest case I think for a lot of people is if like you're given the circumference of a circle and you need to find the radius or diameter based off of that, or if they give you the area of a circle and you have to find the circumference based off of that or vice versa. Those are probably the two harder cases, but I would say you're probably would get maybe one question on that. You know, if you get a really hard version of the test, I wouldn't expect to get you know, multiple questions on really hard circle stuff like that, but anything's fair game. But I think that you should be prepared for the majority of circle questions if you understand the example later in the video. Now, Pythagorean theorem is also a big topic, and this is a popular topic that a lot of people would like to know about and know how to do. You'll definitely want to use the Pythagorean theorem, know how to do that. For sure. You might get word problems, and I've covered this and I couldn't even tell you how many videos on my channel, but we're going to cover it again here in this video. So if you're new here, or if you haven't seen me talk about this before, don't worry, we're going to go over it later in the video, but this is another important question that does come up a lot. And now here's another thing here. It says volume and surface area of three-dimensional shapes. It says find the volume and surface area of three-dimensional shapes, including rectangular and right prisms, cylinders and right pyramids. Find the side lengths, radius, or diameter of a 3D figure when given the volume or surface area. And again, it just reminds you here that you'll be provided with those formulas. Now, I want to make a comment here just so you understand that, you know, we're going to be looking at an example of finding the volume of a sphere in this video. If you're just looking to pass, and there's nothing wrong with that, because passing the test, that still requires a lot of hard work and a significant and respectable amount of hard work and effort on your part. A lot of people work very hard to get a passing score, but just know here, if you're looking for a passing score rather than like a college ready score or something like that, you're probably going to be fine for most of these types of questions if you understand the example with the sphere. And then some of the more, you know, abstract stuff like right prisms and cylinders, right pyramids, that kind of thing, you know, you might be able to figure those out just based off of this one example. But, you know, I personally think that you're only going to forfeit. You might get a couple questions on this stuff that you won't know how to do, but I personally think that if you're just looking to pass, you don't need to spend a whole lot of time studying all this volume and surface area stuff outside of the basics. You know, just know that you'll be forfeiting, you know, maybe a couple questions if you don't study it that in depth. But like I said, you don't need to get every question right to pass. You're probably going to want to get at minimum half of the questions right to pass. You might need more than that, but give or take, half of the questions is what you generally want to aim to get right for a passing score. And that's just a minimum. Obviously, you want to try to get every question you can right. But just for the sake of your study time and your sanity, you know, if you're just looking to cross that finish line and get that passing score so you can move ahead, I don't think it's worth spending a whole lot of time on all this surface area stuff. You might get a couple questions on it for sure, but you know, you can kind of get lost and kind of go down the rabbit hole with all these volume and surface area type questions and 3D shapes. There's a lot of stuff to know, and there's a lot of stuff to know for really probably only a few questions on the test on it. So again, you know, it's up to you to decide. Of course, it's only going to help you the more that you learn. Now, if your goal is to get a really high score, or you're trying to, you know, get a perfect score or something like that, unfortunately, you are going to have to know and study every single little thing on the slide. You know, that's just how it is here. But let's be real here. You know, if you just want to get that passing score and, you know, move on to the next phase of your life, then I wouldn't expect you to get more than a few questions on this stuff, honestly. You know, no guarantee, but I don't think it's worth putting a ton of time into studying this stuff relative to the other topics. You know, but that's up to you to decide. And it also says here, graphical data, including graphs, tables, and more. It says construct and explain data from bar graphs, circle graphs, dot plots, histograms, box plots, tables, scatter plots, and line graphs. And you're going to get all kinds of questions with graphs and data on social studies and science as well as math. This is stuff, in my opinion, the best way to get it is just kind of look at practice examples. So if you have a GED test prep book or something like that, you know, I would say that would be a good place to get more practice with graphs of all kinds of different varieties, like circle graphs, scatter plots. I do have some videos on my channel for sure where I talk about using graphs, but that's kind of one of those things that, you know, just takes a little practice to get. And of course, there is an example where you'll get some practice here in this video. Now, the last topic that we're going to cover in this video, I know we're going to pack a lot of stuff into this one video, so I decided to split this up into 2 video series. Like I said, it might go on to 3 if it gets too long, but basically just know that we're also going to look at mean, median, mode, and range. And I think that after this example that you're going to see here and my additional notes I add to it in the video, you should know how to find the mean, the median, the mode, and the range for a number set. Now, what throws people off a lot of times is how to find a missing value when given an average. I'm not sure if maybe it's just I'm really bad at explaining this, or what, but whenever I use an example in a video where I give a question where it says find a missing value when given an average, a lot of people really have trouble understanding how to do that. I'm not sure exactly why. If it's my fault, then I'll own up, I'll take responsibility for that. Not sure why, but whenever I show examples of that, a lot of people have a lot of questions on that. So maybe it's just a very difficult topic to grasp, but we're not going to look at an example of that here in this video. We're just going to look at finding the mean, median, mode, and range of a number set. And that's the reason is because on the GED official study guide, they give you an example problem that involves finding the median, and I explain how to do the rest of the stuff. But they don't give you an example of finding a missing value when given an average on the study guide. They just list that as something that you should know. So again, if you're looking for that really high score, or you just want insurance that you know enough to pass beyond learning the basics, then for sure it's not going to hurt to learn how to do that. And I have a video, the ultimate guide to mean, median, mode, and range, or something like that. I called it. I made it a couple years ago now, where I do give you an example question. I think I've done it in other videos on my channel too, where I talk about how to find that missing value when given an average. But that is just a topic for some reason that gives a lot of people trouble. I don't personally think it's that hard, but for some reason it seems to be a struggling point for some people. So again, if you are pressed for time, you don't have to learn that. You might get a question at most on the test that asks you to do that. So you'd be forfeiting one question if you don't study that. It's up to you to decide if you can live with that or not. But for the sake of time, and for the sake of your sanity, might not be worth spending much time, if any, on that. You might be forfeiting a question or two, but you don't need everything right to pass. So it's just up to you to decide what's best for you. So let's get into the practice problems. So the first question says, between which pair of decimals should 4/7 be placed on a number line? And I'd like you to try this question first without a calculator, and then you're welcome to use a calculator if you get stuck. And then we'll go over it. So I'd like you to pause the video, give it a try, and then we'll go over it. Okay, so this is a really important question to understand because there's a lot of key concepts here. And the first key concept to get, not just for this question, but for other questions throughout the test with fractions, is the concept of whether or not a fraction is greater than half. So the first thing to know is that the top number of a fraction is called the numerator, and the bottom number is always called the denominator. Okay. So what we can do is look at our denominator, which is 7, and let's think, what is half of 7? Well, half of 7 is 3.5, okay? And now we want to look at 4, and we want to think, is 4 greater than 3.5? Yes, it is. So since 3.5 out of 7 is 3.5 over 7 would be equal to half in this case, 4/7 is going to be something greater than half. All right, and so half is equal to 0.5. So anytime you have a fraction, the fraction can be converted into a decimal, and just one value that you should memorize for your test is that 0.5 is equal to 1/2, or 1/2, however you'd like to say it. So we can eliminate A and eliminate B because 4/7 is greater than half, as we've just proved. So A and B can't be correct here. All right, so the next thing that we want to do is we want to figure out, is 4/7 greater than 0.6? And is 4/7 greater than or less than 0.7? So let's just look at answer choice C here. And what about 0.6? How can we convert 0.6, the decimal, into a fraction? And fortunately for us, 0.6, we can just rewrite that as 6/10. And the same thing with 0.7. 0.7 is just going to be 7/10 when we convert it to a fraction. Now, I know there's someone out there watching this, maybe you were wondering, well, how about 0.5? Wouldn't that just be equal to 5/10? And the answer is yes. 0.5, you can certainly write it as 5/10, but it's not in simplest form. So if we simplified it, 5 divided by 5 is 1, 10 divided by 5 is 2, so that's how we would get that to be half. Now, this fraction here, 6/10, is not in simplest form, but that doesn't matter in this case. All right, so what I want to do now is take the 6/10, and I want to compare it to 4/7. And to compare fractions, we need to get a common denominator. So 4/7, I'm going to get a common denominator by multiplying both the bottom number and the top number in the fraction here by 10. And so when I do that, I'm left with 40 over 70. Now I'm going to take the 6 over 10, and I want to get a common denominator so that we can compare the fractions. I'm going to multiply the top number by 7, and I'm going to multiply the bottom number by 7 as well. And so unfortunately, you're just going to kind of have to memorize basic times tables like 6 times 7. And if you don't use them every day, you know, it's really easy to forget them, but it would be worth reviewing those, I would say, for sure. Although for most of the tests, you will have access to a calculator, but not always, which is why I wanted you to try this without a calculator. So to walk through this without a calculator, you would then, you know, you've got a common denominator between 4/7 and 6 over 7. So 40 over 70 compared to 42 over 70, the denominators are the same. The fraction that has the bigger number in the numerator is the bigger number. So 42 is bigger than 40. So therefore, 42 over 70 is a bigger fraction. So 6 over 10, we turned it into 42 over 70. And we know that 42 over 70 is bigger than 40 over 7. We know, therefore, that 6 over 10 is the bigger fraction. So 6 over 10 is bigger than 4 over 7 for the reasons that we've just proved here. So we know that 4 over 7, it's bigger than 0.5 but less than 0.6. Therefore, C is the correct answer. And if you were able to use a calculator for this, all you'd have to do is just do 4 divided by 7 in your calculator. I think I remember when I did this before I made the video. Hopefully I remember correctly that that was equal to 0.57. So if you did it with a calculator, it would take 1 second. Do 4 divided by 7, you get 0.57. You'd have to say, well, that's in between 0.5 and 0.6, and that's all you would have to do. Question 2. Susan and Daphne are participating in a walkathon at the local community college track to raise money. Susan can walk around the track in 4 minutes. Daphne can walk around the track in 6 minutes. Susan and Daphne started walking at the same time. How many minutes will it be until they complete a lap at the same time? Okay, why don't we have you pause the video, try this out, and then we'll go over it. Okay, so let's go over the question. So you can think about this in different ways, but the way I recommend doing it is to just look at the number 4 and look at the number 6, and all you have to do is just list out multiples for both until you see a match. So what I mean by listing out multiples is just go through your times tables, right, until you see a match. So 4 times 1 is 4. Now let's check. What is 6 times 1? Well, obviously 6 times 1 is 6. We don't have a match yet. So what about 4 times 2? Well, 4 times 2 gives me 8. And 6 times 2 gives me 12. So, 6 times 2 gives me 12. So I want to keep going until I find a match somewhere along the line. And what I mean by match is one of the numbers in my answer is going to have to be the same. So let me just show you, because we're almost about to crack this question already. 4 times 3 gives me what? Well, 4 times 3 gives me 12. So now, if I look at the answer, if I look at my answers, 4 times 3, the answer is 12, and 6 times 2, the answer is 12, we see that we have a match. And the answer here is 12. So just remember that trick. This is probably the fastest way to do a question like this. Now you could also just kind of think about it and kind of reason your way through it, and you probably come to the right answer, but this is just really a reminder that you want to understand greatest common factors and least common multiples for the GED test. And in this question here, what we did was we listed out multiples, we found a match, and we saw that the answer was C12. All right, question 3. Let me read this for you. It's parenthesis 2 raised to the 9th power times 3 raised to the 5th power, parenthesis, times 2 raised to the 4th power times 3, parenthesis, all raised to the 2nd power, or squared is another way to say it. So you know the drill by now. Let's have you pause the video, try this out, let's see how you do with it, and then don't worry if you get stuck, because we'll go over it. Okay, so let's talk about this problem now. So if you haven't studied your exponent rules yet, or if you haven't mastered them, then you might not have been sure how to do this question. So let's talk about it right now. So the first thing that I would want you to realize here is that if we pay attention to this second set of parentheses here first, what we can do with this too is we're going to look at the exponent here. So we have 2 raised to the 4th power. The exponent is 4. Our base is 2. And we can take this 2 and we're going to multiply 4 by 2. All right, and now if we look at the 3, we see that there's not an exponent written out. So any number that doesn't have an exponent, we just imagine that that exponent is 1, but we don't typically write it. So imagine that this 3 has a little 1 right here. Then we're also going to multiply 2 times 1. So let me rewrite this now. And it's always helpful to take the time to rewrite things, at least in my opinion. It might take you a little bit longer, but if you get the right answer, then that's all that matters, right? If you don't rewrite something and you try to keep it all in your head, then you run the risk of just getting kind of confused and confusing yourself, and it ends up probably taking more time than it would if you just write it out. And also note that, you know, it takes a little longer to write because I'm writing with the whiteboard. So this is supposed to be 8, right? Because I said we're going to do 2 times 4, which is 8. So this becomes 2 raised to the 8th power. And now our base is still 3. And 2 times 1 is 2. So I've now rewritten the problem, all right? And now the next thing that I want you to see here is that there's a rule when you're dealing with exponents that when you have two numbers that have the same bases, when the bases match, all you have to do is just add those exponents up, okay? And this is true when you have a multiplication problem with exponents. So let me show you what I mean. So we have 2 raised to the 9th here, and we have another number that has a 2 in the base. So what we can do is we can just do 9 plus 8. And we're just going to leave that 2 as the base. So what is 9 plus 8? 9 plus 8 is 17. So that will become 2 to the 17th. Now, we also see that we've got a 3 here, and we've got another base with a 3 in it. So since the bases are the same for 3 to the 5th and 3 to the 2nd power, we just leave that base as 3, and we just are going to add 5 and 2. So 5 plus 2 is 7. And so this is a little bit, we got some work, we got some writing in the way here, but this is supposed to say 2 to the 17th times 3 to the 7th, which means that D is the correct answer. So I have other videos about exponent rules. If you had trouble with this, I'd break it down more in depth in those videos, but this is the correct answer. So let's keep moving now to the next question. Question 4 says, the points -4 and 5 are plotted on a number line. What is the distance in units between the 2 points? So I'd like you to pause the video, give this one a try, and if you get stuck, don't worry, we'll go over it. So let's go over it now. So basically there's, as with most math questions, there's more than one way to think about this and how to get the right answer. But let's start by drawing this out on a number line so that you see what that means. So on a number line, let me start off with 0 here. Okay, so let's say we have a number line and we have 0, and then we've got 1, 2, 3, 4, and we'll go up to 5, right? Because it gives us the points -4 and 5. So we don't really need to draw anything past that. But each of these numbers are points on our number line, really, right? So we've got 0 through 5, and I'm going to draw an arrow here because we really could keep writing numbers out all the way up until forever, right? But there's not really a reason to, because it says the points -4 and 5 are plotted on the number line. So now we have to go the opposite way. So we go the opposite way now. So here's 0, so now we would have -1 and -2 and then -3, and I'm just making a little bit more space here because I got to fit those negative signs in. And so we only need to go until -4, right? Because the range is -4 and 5 here. But you could in theory just keep drawing this out as long as you really want to, but for the sake of time we have no reason to do that. So we've got our points here. We've got -4 and we've got 5, and we want to know what is the distance between these 2 points. So the way I like to think about it is just imagine we've got a little stick figure here, okay? And our stick figure person is going to start at -5 and take a walk all the way to 5, okay? And each number is like 1 step. So if they were to go from -4 till -3, that's like 1 step. Then from -3 to -2, that's like 2 steps. All right, and then 3, 4, 5, 6, 7, 8, 9. All right, so here's our stick figure, and they have gone from -4 all the way till 5, right? And if we count all the steps in between, right, like we just went, 1, 2, 3, 4, 5, 6, 7, 8, 9, we would see that D is the correct answer. And I know that you might be wondering, am I going to have time to draw out a number line on the GED test? You will be given either right now, you're given like an online scratch pad if you're taking the test online, so you kind of have to write stuff out and draw stuff out, but maybe in the future you'll have paper you can use, and if you go in person, you might be given a dry erase board, but you'll have something to write with for the majority of the questions. And you might be wondering if you're going to have time to write out a number line like this. The answer is, if that's what it takes to get the right answer, I would go for it. I don't think it's going to take you that much time to do it, but there is a faster way to do it. And the faster way to do it, which I'm going to show you right now, is we're just going to take the two numbers and subtract them, and then we're going to take the absolute value of the answer. Okay, and if you don't know what that means, don't worry, I'm about to show you. So again, the faster way to do it, let's just subtract -4 and 5. So -4 minus 5, all we do here is we're going to add the two numbers up and bring the negative sign along for the ride. That's how you do subtraction with a negative. -4 minus 5, again, equals -9. So now what we're going to do is let's take that -9 and we're going to take the absolute value of it. So absolute value, basically, it just means the distance from 0. And you might remember this from math in high school, middle school, whenever, or if you don't remember it, that's okay too. But basically, it's just these little bars here. And these little bars are what's called the absolute value. So if you put a negative number between the two bars, it just spits out a positive number. So the absolute value of -9 is just 9. All right, so in other words, the distance from 0 is 9. Okay, so absolute value, it just basically means the distance from 0. And that's really what we're doing here, is we're just finding the distance between these 2 points. And it doesn't really matter because we go 9 steps here. All right, so it doesn't matter that we started in the negatives and ended up with a positive number. We still took 9 steps here. All right, so we didn't take -9 steps. You can't take -9 steps, but you can take 9 steps. All right, so that's my little tangent, my stick figure drawing. Hopefully this helps you. Hopefully I didn't confuse you more, but the answer here is D, and hopefully you stick around because we're going to question 5 right now. Great work. Okay, question 5. So it says simplify 12 plus 15 divided by 3 times 6 minus 4. I'd like you to try this with a calculator, see if you can get I'd like you to try this without a calculator first, and if you can get the answer without a calculator, great, but if you get stuck, it's perfectly okay to use your calculator since we're just practicing here, but this type of question I would say is fair game to be asked to do without a calculator on the test, so I'd like you to try it without a calculator first. So now would be a good time to pause the video, give it a try, and then we'll go over it. Okay, so basically the idea here is this question, I should say, is actually deceptively tricky. It looks pretty simple, and if all you do is just push the numbers right in your calculator and hit equals, it would be very simple, but without a calculator, it's a little bit trickier, right? It's not super hard, I don't think, but it is tricky. So the main concept here that you have to understand for not just all questions on the test without a calculator, but also many questions with a calculator is PEMDAS, right? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction is what this stands for here. And I'm going to go over this concept kind of fast because this is going to come up again and again throughout the video here. But just note that whenever we start a question, we want to just go in order. Parentheses, exponents, multiplication, division, addition, and subtraction. So in other words, you would never want to start a question like this by doing 12 plus 15 or 6 minus 4 because you would be doing operations out of order and you won't get the right answer. So if you did that, don't worry about it right now. We're just practicing, right? It's just something I want to draw to your attention so you can maximize your score on the test. Now, there's one caveat to this though, and along with the parentheses, you have to note that fraction bars are going to also be treated as parentheses. And this is a kind of a subtle nuance with math and with Please Excuse My Dear Aunt Sally that a lot of people miss because it's not really that obvious, so I'm going to show it to you right now. And basically, when we see this 15 divided by 3, what I highly recommend doing if you see something like that on your test is just rewriting it like this, 15 over 3. And now, what you really have to understand here is that this 15 over 3, this now puts a fraction bar into our scenario here. And when you have a fraction bar, you have to treat that like parentheses. So this is just why I'm spending a lot of time just explaining this concept, because this is really, to get this question right, you either have to just put it right in your calculator and spit out the answer, which I really wanted you to try it without doing that first. But to get this right without a calculator, you really kind of need to understand this trick. And, or at least in my opinion, you might have another way to approach this where you don't need to do that necessarily, but basically you would want to start with whatever's in the parentheses first. And it's not immediately obvious, I don't think, to a lot of people that 15 divided by 3, that you'd want to rewrite it as 15 over 3 like this, so that you would say, hey, there's a fraction bar here, that's just like a parentheses, so I need to deal with this first. But that's just what I'm telling you now, so you know. And if we rewrite it, we would rewrite it as 12 plus 5, because 15 divided by 3 is 5. So 5 times 6 minus 4. All right, so now the next thing that we have to see here is that we've got multiplication. And so we've got rid of everything in parentheses. We don't have anything with exponents to worry about. So the next step would be to look for multiplication. So we have our 5 times 6. So we would want to deal with that next. So let me draw an arrow here showing that I'm rewriting it. And what is 5 times 6? Hopefully you know that that is 30. And 12 plus 30 minus 4 is what we're left with. So we now want to deal with our addition and then subtraction. All right, and so what is 12 plus 30? Well, 12 plus 30 is going to be 42. And if you really wanted to, you could line them up like this, and that's perfectly okay if you have to do it that way, just so that you can visualize it a little bit easier. In fact, I recommend doing it if it's hard for you to just kind of look at this 12 plus 30 and just see that it's 42. But we do 42 minus 4, and that's going to give us 38. Now, if you got stuck and you're trying to remember what is 42 minus 4 and you're having trouble with that, you could also just think here, 42 minus 4, it's not going to be 18, that's way too low. It can't be 50 because you're subtracting from 42. And 22 just seems, that's way too low, but 38, that seems about right. So if you get stuck and you're not quite sure how to figure that out, you could just do 42 minus 4, kind of line it up. And if you did it that way, what you would have to see, so you'd have to borrow, you'd have to go to this 4, cross it out, turn it into a 3, you'd have to borrow. So now you would have 12 minus 4, which is 8, and you bring the 3 down. So, at any time that you need to, especially for no calculator questions on the test, always just write stuff out and just take your time with it. But you can also, if you just get to something like this, 42 minus 4, you can just sometimes look and just kind of through logic, just see, well, it has to be, logically, it's close. The answer's got to be 38 or something close to it. 18 is too low. It can't be 50. All right, but regardless, hopefully you got to 38 as the answer, but I just wanted to really spend a lot of time. You're probably tired of me saying it by now, but it's really, really important. This actually isn't really that common. I'm not sure why they put this on the study guide, because this isn't a super common thing on the test, I don't think, but it's something that I don't want you to get this wrong on your test. So just know, if you get a question like this, you see this 15 divided by 3, it's really easy to go through this and think, okay, there's no parentheses, there's no exponents. I want to start with multiplication and try to do 3 times 6 first. And then you're left with a scenario where you have 12 plus 15 divided by, I'm sure someone out there watching this made this mistake, and it's okay if you did, it's an easy one to make, divided by 18 minus 4. So if you tried to do it this way, you were on the right track, because you were thinking, I like the thought process of thinking you wanted to start with the multiplication, the 3 times 6. But the thing that is not immediately obvious, I don't think, to a lot of people, unless this was pointed out to you by somebody before, this 15 divided by 3, that's not just any division problem. That's really, you have to think about it as 15 over 3 like a fraction. And when you see a fraction bar in a question like this, that is treated like a parenthesis. So that should tell you that the first thing you need to start with in the question is that parenthesis. All right, so that's how you get this question right. If you've got another way to do it, let me know down below. There's usually multiple ways to think about questions on math rather than just one straight shot to do it. I spent a lot of time on this question, but now let's move on to number 6. Okay, question 6 says to add 3 square root of 7 plus square root of 7. So pause the video, try to figure this one out, and then we'll go over it. And I should say this too, this shouldn't require a calculator. So I'd like you to try it without a calculator first. If you really want to, you can use the calculator, but I say not to use the calculator because if you just plug this right in, 3 square root of 7 plus square root of 7, it's going to give you an answer, and there's really a key concept that I think you'll miss if you do it that way. So let's have you try it without a calculator first, and then let's go over it then. So take a second, take more than a second, take your time with this question, pause the video, and then when you're ready, we'll go over it. Okay, so let's go over how to do this. And really there's just one trick here, one simple trick, I should say. And whenever you're dealing with an addition with square roots, you need to know that whatever is under the square root, right, the numbers, when they match like this, you just leave that 7 under the square root, and you're going to bring it along for the ride, and you're going to look at the numbers out front of the square root. So one number is 3. Now right here, we don't see a number, but we just have to know that there's like an imaginary 1 right there. And so all we're going to do is we're going to add 3 and 1. So 3 plus 1 is 4. And like I said, we take that 7 right along for the ride here. Now, a common mistake would be to try to do 7 plus 7, which would be 14. And I can understand why you would want to do that. But I mean, it seems like it would make sense. Well, I'll just add 7 and 7. But here, that's not how we get the correct answer. So if you did that, don't worry about it. It's just practice and a good try. You're doing really good work by following along with the video, trying your best. That's how you're going to learn and get better. And let's just hope that for the real test, you'll remember that you're not going to add the numbers under the square roots. When they're the same like this, you just add the numbers that are out in front of the square roots and bring that 7 along for the ride, which would give you A. The next question says, which expression is undefined in the set of real numbers? So I'd like you to pause the video, try it out, and then when you're ready, we'll go over it. Okay, so unfortunately this is one of those questions where you kind of either know the trick behind it or you don't. And if you didn't know the background concept behind this, don't worry, because we're going to talk about it right now. But whenever you see this word undefined, there are really 2 cases that I want you to remember. And this is one of those things, you'll probably want to put this in your notes and just memorize it, but you can never have a negative number underneath the square root. So you can never have this, right? So the first thing I want you to remember is just you can never have a negative number underneath the square root. This little symbol right here, this bracket thing, this is a square root sign, and I have a negative sign right here, which looks like a minus, and A could be any number here, right? This could be 10, 1,000, it doesn't matter. You can't have a negative number underneath the square root. And the other case that you'll want to remember here is that you can never divide by 0. All right, so it doesn't matter what number you put up here. This could be, again, A could be any number. It could be 1,000, 99, 1, 2, 3. It doesn't matter. Whatever number you put in here, you can never divide by 0. And you can check your calculator right now. You can put in any number. Try 9 divided by 0. Your calculator is going to give you an error message. So if you ever see either of these things, either a negative number under the square root or you see dividing by 0, know that the expression is going to be undefined. Okay, you might also see the word function. Which function is undefined? All right, and it's a similar concept here, so don't be thrown off by that if you see the word function. I want you to remember these 2 cases. No negative numbers under a square root, and you can't divide by 0. So now let me show you one more thing here, and this is a bonus tip, but you're more likely to get a question that asks you something like this, where they will give you something like this maybe, and I'm just going to pick really simple numbers here, but this is important to understand. Let's say you've got, say, x minus 2 down here, and any random number, let's just say 10 up here. So they'll probably give you more complicated numbers, but I'm just picking a really basic example. They might give you, a function, or they might call it an expression like this, and they might say, for which value of x is the function undefined, or for which value of x is the expression undefined, or they might word it a little bit differently. But basically all you're going to do is you're going to take the denominator, which is the bottom part of the fraction, in this case that's x minus 2, and you're just going to set that equal to 0. So I would write x minus 2 equals 0. And I set it equal to 0 and I want to solve for x. So to solve for x, what I mean is we want to get x on one side of our equation. So since we have x minus 2, I want to do x plus 2. Whatever I do to one side, I do to the other. So I'm going to add 2 to both sides of the equation. And minus 2 plus 2 cancels out, so I'm just left with x equals 0 plus 2, which is just 2, so x equals 2. So what does that tell me? Well, whenever x equals 2, this function is going to be undefined, or the expression. Again, they might use those words, but basically it's the same principle. The expression is going to be undefined when x equals 2. Well, why is that the case? Well, let's take this x equals 2. If I substitute 2 in for x, what's going to happen? Well, 2 minus 2 is 0, and you can't have 10 divided by 0. Okay, so just keep this in mind, all right? I know that some people might have skipped to the next question, and that's totally fine. I mean, it's your choice to depend how you want to use your time, to decide how to use your time, I should say, but this does come up a lot. This, which value for x makes the function undefined or expression. They might change the wording up a little bit, but you're just going to take the denominator, set it equal to 0, solve it for x, and that's going to tell you. All right, so these are the two things I want you to memorize, and just be aware that there's this third case where you just set the denominator equal to 0 and solve for the variable, and that's probably going to give you the right answer. Okay, question 8 says, a store charges $6.96 for a case of mineral water. Each case contains 2 boxes of mineral water. Each box contains 4 bottles of mineral water. Question, what is the cost of each bottle of mineral water? So you can pause the video, I'll give you a chance to try this, and then we'll go over it. Okay, so the way I would like to approach this question, and it's okay if you come up with a different way, but following the units is going to be really important here. And if it sounds like I'm speaking a foreign language to you, then don't worry about it because I'm going to show you what I mean. But paying attention to the units here is just really key to getting this right. So let's first take all the information we're given, and I'm going to translate it into math terms, right? So it says each case contains 2 boxes of mineral water. So in other words, I can rewrite that as there are 2 boxes. So I'm just going to put box. I'm not going to write out the word boxes for the sake of time, but I'm just going to write there's 2 maybe I will. So there's 2 boxes per 1 case. Okay. And this is really important to understand what I'm doing here because we're just kind of follow the units here. So let me take this statement next. And so this tells us that each box contains 4 bottles of mineral water. So what am I going to write here? I'll put 4. Let me just write the word bot. I think we understand what that means. So there's 4 bottles per what? Per 1 box. So hopefully we don't get bot and box confused here because my handwriting, it's not much better in real life, but it's even harder to write with this pen here. So I will write out the word bottle, so I don't want us to confuse that. So this says 4 bottles per 1 box. All right, and we also have a store charges $6.96 for a case. All right, so we don't really need an arrow. I'm just going to put that right here. So for one, let's see, it's $6.96. So I'm going to put the unit for this is going to just be dollars, right? So I'm going to put a dollar sign, $6.96 per 1 case. And really on your test, if you want to write this all out by hand, it's not going to take you this long. I'm just going slow because it's harder to write with this electronic thing, and it's also because I'm trying to explain this. But on the test you might say it's going to take too long to write all this out. That's up to you to decide, but I think if it helps you get the question right, then it's another question that you can get right, which can help you pass or get a higher score. But basically now what we have to look at is what the question wants us to find. It says, what is the cost of each bottle of mineral water? So what we're trying to find here, all right, is we need to find something where the units are going to be cost of each bottle of mineral water. So we want to find something where the units are going to be dollars per 1 bottle. All right, and it might sound like I'm speaking gibberish to you, but I promise this is really, really important to understand. So we want to look at these 3 different statements I have up here. 2 boxes per 1 case, 4 bottles per 1 box, $6.96 per 1 case. And we want to kind of do some math terms here so we can kind of cancel units that we don't need out, and we want to be left with something where we have dollars over 1 bottle. All right, easier said than done, but let's try to figure this out here basically. So what can we start with? Let's start with this $6.96 per case, right? So if we've got $6.96 per case, all right, we know that we can do a little math here, and I'm just going to put 1C for case. So we know that we can do a little bit of math here, and we can take this 2 boxes per 1 case, And what I'm going to do is I'm going to flip it upside down. And you might say, why am I flipping it upside down? Well, it's because I want the units to cancel out. And again, I'm just writing C here for case. So hopefully that's clear. I'm just going to put box here. It's 2 boxes, but I don't want to take forever writing things out here. So it says $696 for 1 case, and we already know that for there's 1 case per 2 boxes, right? And so basically what I can do is I do a little bit of math here. So the units are going to cancel out here, right? Because I've got 1 case and I'm dividing by 1 case. So what is 696 divided by 2? Let me do that. 696 divided by 2 in my calculator, and that gives me, let me write it down here, $, right? Because the dollars don't cancel out. $3, and that is a 3. 348 divided by what? Divided by box, right? Or boxes. And you say, isn't it 2 boxes? Nope, because we did 696, right? So we now know the cost per box, right? So we did 696 divided by 2 boxes, and the cases cancel out. We're left with, we know now that it's $3.48 per 1 box, right? I said boxes for some reason here. All right, and so now what we want to do though, we need to find out the cost per bottle. So we look at this here, 4 bottles per 1 box. So what am I going to do? I'm going to do a similar thing, and I want to take this 4 bottles per 1 box, but I want to flip it upside down because I want the boxes to cancel out here. All right, so again, we're just kind of what I like to call following the units here. And this seems very confusing, so I would recommend if you're having trouble following this to just watch my explanation and just maybe try to pull out a sheet of paper and just try to solve this problem and maybe walk through it. You know, maybe teach this out loud to somebody or just explain it to the wall or something to make sure you've got this, because it does seem very, it can seem very confusing if you've never done this before. But basically, now what I'm doing is I see again, the boxes are going to cancel out. 1 box divided by 1 box, right? That's going to cancel out. And so now what I want to do is 348 divided by 4. And that's going to give me 0.87, right? 0.87. And here's the important thing to see here. All right. The units, it's 0.87, right? So 87 cents over 1 bottle. And remember how before we jumped in and did all the work here, I said what we need to find is an answer in, with dollars over 1 bottle. And what do we have here? We have, dollars, we have 87 cents over 1 bottle. A is the correct answer here. So this is how I would approach this. I know this seems kind of complicated, but I would make sure you understand this because this is an important concept to get. There might be other ways to think about this and work through this, but as long as you got A, I'm sure your way of doing it was valid. Though let's keep rolling here. Good work. Question 9. A scale drawing of a house uses a scale of 0.5 inches in 2 feet. What is the length in inches of a line on the scale drawing that represents an actual length of 5 feet? So you can pause the video now and try this out and then we'll go over it. All right, let's go over this. And I want to say thank you for sticking with me so far, and I'm really trying my best to teach you not just how to get each question right, but also the skills and concepts you need to know to get other similar questions right. So thank you for bearing with me so far. I know that sometimes I go off on tangents, but I promise there is a method behind this, and I'm really glad that you're here with me, and hopefully this is beneficial to you. So to do this question, what I would do is first, you want to take this relationship that you're given, 0.5 inches and equals 2 feet, and I would rewrite it like this, 0.5 inches over 2 feet, all right? Simple, hopefully that makes sense. And that's gonna really help us because this is kind of another one of those following the units questions. It's just a lot simpler than the last one. So it says, what is the length in inches of a line on the scale drawing that represents an actual line of 5 feet? So actually, all we really have to do here, and let me get rid of this arrow, is, okay, we're gonna start with the 5 feet that were shown, and we are just knowing that 2 feet is equal to 0.5 inches. We just want to just multiply, and we're setting this up again so the units are going to cancel. So this is just like what we did in the last question, but it's much simpler actually because feet are going to cancel out and our answer is going to be left in inches. So all you would do is 5 times 0.5 divided by 2, and the answer is A. So hopefully this makes sense. Okay, the next question says, the price of Veronica's meal before tax and tip was $11.92. Veronica paid 8% tax, then added a 15% tip to the total. To the nearest cent, how much did Veronica pay for her meal? So you can pause the video, try this out, and then when you're ready, we'll go over it. Okay, so let's get into this one. So basically, we just kind of have to follow the instructions here. So let's start with the $11.92 before the tax here. And so basically, she paid 8% tax. So the first thing we have to do is let's figure out what is 8% of 11.92. So 8%, that is the same as 0.08, okay? And when we convert that percent to a decimal. And so basically we would start by doing 0.92 times 0.08. And so unfortunately we're gonna get some kind of long numbers here, which is unfortunate, but I think that you're welcome to try to round these earlier, but I would usually just keep it as 0.9536 for now, and then when you go back later on to find the final answer, then I would round it to the nearest cent. You could, in theory, do it earlier on, but the reason why I wouldn't recommend that necessarily is because look at the questions here, or look at the answer choices here. See how the numbers are all relatively close together, like 1466 and 1480, 1287, 1371. These are all relatively close to each other. And I just feel like if you're going to round early off, like it's going to make the numbers shorter to deal with, but if you're going to start rounding things earlier on, I just feel like you might, since all the answer choices are relatively close together, it might throw you off at the end, because if you're rounding, you're probably not going to get one of these exact answer choices if you round in earlier steps in the problem. So I just wouldn't recommend doing that, and that's why. But again, you might get the right answer doing it that way. But so all I'm doing here, what I did was I first did 11.92 times 0.08. And again, the reason I'm doing that, I want to find what 8% of $11.92 is. But then I found that that was 0.9536. So now I want to add that back to 11.92 to figure out how much she paid with the sales tax. All right, so I just add that to 11.92. And again, I'm going to get a long number here. It's 12.8736. And you know, you could, like I was just saying, to keep beating a dead horse here, you probably could just leave this as 1287 and just cut off the 36, basically rounding this to the nearest cent right now. But again, I probably wouldn't do that just because the answer choices are so close together. It might confuse you when you get the final answer, but it might not. It just depends on your preference here. But it says then added a 15% tip to the total. So what we have to do now is we have to find out what is 15% of 12.8736. Then we're going to add that to 12.8736. All right, so 15%, if we convert that to a decimal, that's just equal to 0.15. So in my calculator, I'm going to do 12.8736 times 0.15. Okay, and so what I get is 1.93 104. And again, I'm just going to leave the whole number here. If you want to round it to the nearest cent earlier on, it's up to you, but I wouldn't recommend it again until the final step. And so now what I'm going to do is I'm going to take this and I have to add it back to this 1287.36. So I've got 12.8736. Okay, so now let me add that up in my calculator here. 8736, and so what I get is 14.80464. And now to round to the nearest cent, all you have to do is, let's say we've got right here, so you want to just look at the hundredths place, right? Or you want to just basically just look at the decimal and go over two places, which is the 0 here, then look at the number next door. If it's a 5 or greater, I would have to round this up, but it's not, it's a 4, so I leave it as 0 here. And so it's 14.80 is just going to be my answer here. All right, and so hopefully that makes sense. A rectangle has an area of 54 square inches and a length of 6 inches. What is the width in inches of the rectangle? So pause the video, try this out, and as always, we'll go over it. Okay, so the first thing that you need to know here is what is the formula for area of a rectangle, right? So I'm going to put A with a little r here. This represents area of a rectangle, all right? Yeah, I'll write rec out here. So area of a rectangle. That's okay, and that is equal to the length, which I'm going to abbreviate as L, times the width. And here we're being asked to find the width. And we're actually given a rectangle has an area. We're told that the area is 54, and we're told that the length is 6. So I can take this 54, and I can substitute it in for the area. Likewise, I can take the length, which I'm told is 6 inches, and in the equation here where I see the letter L, I can plug a 6 in there, and I'm going to rewrite it. So again, the area, we're told, it has an area of 54 square inches, so where it says area of the rectangle, I'm just going to rewrite that as 54. And the length is 6, right? So I'm going to replace this length with a 6th. So let me put 6, and we don't know what the width is, so I'm just going to leave that as W. And so what I want to do is solve this equation. I want to find out what W is. So in other words, I need to get W by itself on one side of the equation. So this is 6 times W here. And in order to get just the W, since this is 6 times W, I have to do the inverse operation. In other words, the opposite operation, which is division. So I'm going to divide by 6, and what that does, if I do 6 divided by 6, they're going to cancel out, because 6 divided by 6 is just 1. 1 times W is still W, and I have to, whatever I do to one side, I always have to do it to the other. So I'm going to divide by 6 over here as well. So 54 divided by 6 is going to be 9, and a trick to remember your 9's timetables is that, see how 54, 5, and 4 add together to be 9? Just a little trick to help you remember that 9 times 6 is 54. But anyway, the answer here is just going to be 9, and hopefully this makes sense. Okay, so this question, there's a lot going on here, so it's kind of big, so I had to stretch it out to fit on the screen. The text is a little small, so let me read this out loud in case you're on a cell phone or something like that, and it's hard to see the text because it's a little small, but it says, the Wilson family's backyard is a rectangular plot that has a length of 100 feet and a width of 80 feet. The family planted a garden with a length and width of 60 feet. The family planted a lawn in the remaining area of the backyard as shown. Now down here is the actual question, and it says, what is the area in square feet of the lawn in the Wilson's backyard? And I put the answer choices A, B, C, and D over here just because this is the best way I found to fit this all on the screen here. So I'll have you pause the video now if you'd like to try this out, and then we'll go over it. Okay, so this question, it's kind of set up in a little bit of a tricky wording here, I should say. The wording's a little bit tricky, but basically this, I'm just drawing kind of a dotted line here because the way I look at it, the entire yard is like this whole entire rectangle here, but for some reason they don't show the whole rectangle here. And basically the way I look at it is they planted a garden that has a length of 60 feet and width of 60 feet. So this little square right here, which I'm right now tracing with the line, plus the dotted portion, right? This whole thing is the garden. So let me just label that as G. Okay, this part of this portion right here, again, it's really a square because a square, all sides would be the same length. So this would be 60 feet, 60 feet, 60 feet, 60 feet. That's just, remember that about a square, all 4 sides are the same length. But so we've kind of got this square going on here, which is their garden. And basically out of the entire rectangle here, what we want to do is find the area of the whole rectangle, find the area of the garden, and we're going to subtract them. So again, the area of a rectangle is just, I'm just going to put A here for area, and I'm talking about of a rectangle, its length times width. Okay, so for the entire yard, or the entire lawn, right, we know that, for the entire backyard, I mean to say, what we want to do is we want to take the length of 100 feet, and we're going to multiply it by the width of 80 feet. Okay, so for the area for the entire backyard, so let me put area, I'm going to put a little b and y right here. So the area of the backyard, it's going to be 80 times 100. Okay, and if you do this in your calculator, you crunch the numbers, that is equal to 8,000. So that's the area of everything. Now, what about the portion here that it says the family planted a garden with a length and width of 60 feet. Okay, so what about this garden right here? All right, what is the area of this? So let me put here the area of the garden. And it tells us that they planted the lawn in the remaining area of the backyard. So this whole area in here, basically, that I'm scribbling out, this is what I believe this is the yard in here, okay? So the area of the garden is going to be the same thing, length times width. We know that everything, all sides are 60, so the length is 60, the width is 60. So 60 times 60, let's crunch that in the calculator. 60 times 60 is 3,600. And what we want to do is we want to find the area of the lawn, the area of everything else. The whole part that I'm kind of scribbling out here very sloppily, this is the lawn, all right? The whole thing's the yard. This little square right here is the garden. Everything that's left is the lawn portion of it. So let's take the area of the whole backyard, which we found was 8,000, and we're going to take the area of the garden portion, which is 3,600, and we want to subtract them. And if you do that, you'll find that A, 4,400 is the correct answer. Good work on that one if you got that one. That's a tricky one. Okay, so the next question here, and again, I kind of had to fit this on the screen the best I could, so the multiple choice answers are actually above the question itself, so sorry if that's confusing, just how I could best fit it on the screen here. But it says, Greg installed a circular drain that has a diameter of 4.8 inches, and I'm pretty sure in the GED testing guide, I'm pretty sure they messed this up. It says 4.8 centimeters. Pretty sure, or in fact, I'm positive that was supposed to say inches, but just know that that should be 4.8 inches. They had that like that in the study guide, but it says the actual question, to the nearest tenth of an inch, what is the circumference of the drain? So as always, I'd like you to pause the video, try this out, and then we'll go over it. Okay, so really this question basically sums up almost, I would say, basically everything you need to know to get circle questions right on the GED, and I hate to make it sound like circles are this simple, but there's not really that much more to it than what I'm about to show you right here. Now, you might get a little bit more complicated word problems or something a little more complicated, but I wouldn't expect it to be much more complicated than as long as you understand what I'm going to tell you right now. So there's really three main formulas as far as I'm concerned that you should be aware of how to use for circles, and my writing's a little sloppy, so I'm going to clarify what I mean here by these, but the first one is the circumference equals 2 pi r, and of course this is what we're going to be using in just a second, but I really believe that in order to maximize your score, it's not just about knowing the answer to this one question. You have to know how to get other circle questions right on the test, because you might not get a question that gives you this exact scenario. It might ask you about the area or something else. So this is why I want you to also see that you might also need to use this formula. Area equals pi r squared. And there's one more thing that I want to show you here as well. All right, so the diameter of a circle is always equal to the radius divided by 2. Or I'm sorry, double the radius. The diameter equals 2 times the radius, and so we can also say that the radius equals the diameter divided by 2. Okay. So essentially all of this right here, if you understand how to apply each of these formulas in problem solving, I mean, I hate to make it seem like it's this simple, but this will get you through, I would imagine, probably 90% of circle questions you might get, if not all of them on the test. Really isn't much more than this. You just have to know how to apply these things. And so in this case, the first thing to know is that we are going to use this formula C equals 2 pi r. But in order to get r, we have to first take the diameter and cut it in half here. Okay, because remember, we're given the diameter is 4.8, but we need to find the radius so that we can plug the radius into the formula. So all we have to do to find that radius is we take the diameter and we cut it in half. All right, in other words, we divide by 2. So we have r equals 4.8 divided by 2. And I'm just using this formula right here. This is all this is. It's the radius equals the diameter divided by 2. All I'm doing here is I'm taking my diameter, which is 4.8, I plug it into the formula for d, and I divide by 2. So 4.8 divided by 2. What does that tell me? It tells me that the radius of the circle is equal to 2.4. And now I have what I need to solve the problem here. So I take this radius value and I just plug it in here. Oh, there's one more thing I should add that's really important to know. And pi is this really long number, but for our purposes, you just have to remember that it's equal to 3.14. it's not really equal to 3.14 because there's this long number that just keeps going on and on and on and on. But you know, so really I should say this is pi is approximately 3.14. It's not really 3.14 because it keeps going on and on and on, but for the GED, just remember pi is 3.14 and life will be just fine for you. And we now want to use that formula. So circumference equals 2 times pi, which again, you can just plug in 3.14, and we want to multiply by our radius, and we did some work to find that the radius is 2.4. So I now have this set up the right way. The circumference equals 2 times 3.14 times 2.4. All right, and again, to get that 2.4, to get the radius, I took the diameter, I cut it in half. 3.14, we're using that number because pi stands for pi you can just remember is 3.14. Again, that's not mathematically correct, but that's all you need to know for the GED is that pi is 3.14. And so I do the math in the calculator, and what I get is I get the number 15.072, and all we would have to do here, it says round it to the nearest tenth of an inch. Well, this would be the tenths place right here. We look at the hundredths place, it's a 7. Since it's a number 5 or greater, we would round this up to 1 and replace everything with zeros, and B would be the correct answer here. Okay, the next question. The foundation of a building is in the shape of a rectangle with a length of 20 meters and a width of 18 meters. Now the actual question is down here. To the nearest meter, what is the distance from the top left corner of the foundation to the bottom right corner? And I put the answer choices right here above the question just because that's how I could fit it all on the screen. But they say A is 19, B 27, C 36, or D 38. So let's have you pause the video, try this out, and if you get stuck, absolutely no worries because we're just going to go over it, and all that means is you've got something to learn. Okay, so the first thing I want to do here is the question says, what's the distance from the top left corner? So let's find that. Here's the top left corner to the bottom right corner. So let me just trace a line here. And we want to figure out what is the length of this portion of our rectangle here, all right? The length right here. We want to figure out C, and I'm just calling this C, is equal to what? Now, why am I calling this portion here C? Well, you may or may not have realized that what we're dealing with here, all right, is a right triangle. So we cut this, it says foundation is the shape of a rectangle, and we're given this little box type thing down here. And this is a big kind of hack to math on the GED. Whenever they're generous enough to show you one of these little box type things in a question, all right, what you need to know is that might be a tip-off that you have to use what's called the Pythagorean theorem. So watch out for these little box type things. They won't always give it to you like this, but if they do, okay, you need to know that little box type thing represents a 90-degree angle. So we've got one straight line going this way, one straight line going this way, and when they cross, it forms this little 90-degree angle. And the important thing, though, to recognize is that when we have a right triangle, which is another word for a triangle that has this 90-degree angle, we can use a formula called the Pythagorean theorem. And so really, I think the hardest part about Pythagorean theorem questions is first understanding that you have to use this special formula right here. So if you didn't know you would use this formula for this question, you can pause the video again now that I've given you the formula, and you're welcome to take another stab at it now that I gave you this formula. But if not, let's break it down right now. And so basically the formula says a squared plus b squared equals c squared. And again, whenever you see one of these little box type things down in the corner, all right, of a triangle or even a rectangle, whatever they give you, that's not always going to be the case, but oftentimes it can be a tip-off that you'll have to use this formula. Not always, but again, that's a good rule of thumb, especially if you're stuck on a question. Find that little box type thing in the corner if they give it to you of a triangle, or it could be a rectangle like this. Be aware that really this is almost a square because this side's 18. It's almost a square, but whatever. Let's not split the difference here. Little box type thing, you want to think Pythagorean theorem, which is this formula right here. Not guaranteed it's always going to be the case, okay, but more often than not, they're giving you a clue here. So it doesn't really matter if I plug 18 in for A or 20 in for A. It doesn't really matter. I'm just going to do it this way. Let's just say 18 squared. So I'm plugging 18 in for A, but whether I call 18B or 20B, it doesn't really matter that much. Basically, we want to do 18 squared plus 20 squared. And we want to plug this into our calculator, but you have to be aware that this is only going to tell me what C squared is, which that's not what we want. We want to find what C is. So just keep that in mind. So 18 squared, that's the same as doing 18 times 18. 18 squared, or in other words, 18 times 18 is going to give me 324. And then 20 squared, that's the same as doing 20 times 20, which gives me 400. And remember that this is going to tell me what C squared is. Okay, so let me add these up here. So we've got 400 plus 324. And I'm putting this in my calculator right now as we speak, plus 400. And I have 724 equals C squared. So this says 724 equals C squared. 724 equals C squared. So a common mistake at this point would be to say, well, I have to find C, so I'm just going to square this. I'm going to do 724 squared. And for some reason, that's a very common mistake, and it's perfectly okay. Perhaps you made this mistake. Okay if you did, we're just practicing, but know that that's actually not how we want to do it. So we want to find C, so what we have to do is we need to take the square root of both sides. We're not going to square 724. That isn't going to help us. Whenever you have C squared, if you take the square root of that, it's just going to spit out C. And whatever you do to one side, you have to do to the other. So if you do the square root of 724 in your calculator, you'll see that it's a number that rounds to 27, and 27 is C, so that tells us that B is the correct answer here. Okay, the next question is, a sphere has a radius of 7.5 centimeters. We see a picture here. The question, it says, to the nearest cubic centimeter, what is the volume of the sphere? And again, the answer choices are up above the question, just so I could fit it on the screen nicely. A is 236, B is 1,325, C is 1,766, and D says 14,130. And I actually gave you the formula for the volume of the sphere right here, just to save you a little time, so you don't have to dig around to find that formula. So you can pause the video, try this out, and then we'll go over it. So hopefully you had a chance to try this, and as we go along here, I just want to say again, thank you so much for watching this video. Really hope that this is helpful, and just know that you're doing really good work here. I know that it might be frustrating and tedious, especially since you've been on the video for so long. Maybe you've watched part of this and you've came back to it now, you left and you did something else because you had other things going on, and you came back to it right now. But I just want to say thank you for being here, and that you're doing really great work, and that someday it's going to pay off. Maybe not tomorrow, maybe not next week, but eventually it is going to pay off for you. And basically, the way you do a question like this is you just kind of plug and chug. You just kind of plug this into the formula here. And again, pi, what you need to know is pi. For the purposes of the GED, whenever you see pi, you can just use 3.14 in its place. And for the radius here, they actually just gave you that. It's 7.5, so you want to plug this in here and know that you're going to do 7.5 cubed, which is the same as doing 7.5 times 7.5 times 7.5. So you're just going to really just put this in your calculator, just run that calculation, and you'll get something that will hopefully round to 1,766. C is the right answer here, and good job. Next question. The line graph shows the monthly payroll at a large construction company. In which month did the payroll decrease the most? A, February, B, March, C, June, or D, July? So I'd like you to pause the video if you want to, try this out, and then we're going to go over it. Okay, so the first thing to do here is I want us to, let's kind of understand what's going on the graph, right? So it's telling us monthly payroll. Now on our up and down axis, right, or y-axis or vertical axis, it says payroll in thousands, and we see the numbers are going up from 10 to 100. And it's important to see that we're starting with small numbers and we're going up and up and up, because what that's basically going to tell us is that whenever the graph is going in this direction or going up, that means that it's showing increase. Now, whenever the graph is going in this direction or going down, that means that there's decrease. And we don't see an example of this here, but whenever the graph is just flat like this, that means there's no change. And if we see a case kind of like right here where it's not flat, but it's almost flat, that could indicate that there's very little change happening there. So it's the first thing we have to get straight. Now, second thing we have to know is that we're not checking every month. There's no reason to check January, no reason to check May. We only care about these months right here. So let's just go down and see what we can eliminate here. So it looks like this is January, so it looks like, let me just pay attention to what's happening on February here, okay? So to figure out what's happening in February, it looks like we just need to focus on what's happening inside of these lines here, because this would be February. So I see that in February there's a little decrease, and then it changes directions and starts going up. So we see an increase, and it looks, just by looking, I'm not calculating this, but it looks like there's a decrease right here, and then an increase, and it looks kind of like that increase is going to cancel out the decrease. So it looks like for February, just without calculating, it doesn't look like there's much of a decrease because it starts going down, it turns back up, and keeps going up. So I would say February is out just based off of just eyeballing it. So next, let's check March. So it looks like now March, okay, we just have to look at what's going on right here. And so this portion of the graph is March. So we're going to look between this line and this line. So I would like you to just focus on the line right here. So what we see is that we see the month starts off with a pretty big increase, right? And it looks like the start of the month corresponds to about 60, and then it looks like about halfway through the month it goes up to 70, so it goes from about 60 to 70, so which is a big increase. Then we see just a little tiny dip there, but not much, so it looks like a big increase followed by a little bit of a decrease. So I wouldn't say overall it does not appear that there's a big decrease in March, so March will probably be ruled out as well. So let's check June and July next. So it looks like June would be right between these two bars here, okay? So the thing I notice about June is that the whole time there's a decrease, right? So from the start of the month, we see the graph's going down, then it's going down some more. So June looks like it's all decreased. There's no increase here. Now, let's also check July. So in July, July would be in between this bar and this bar on the graph. So we see that the graph is going down. So there is a decrease in July, but it looks like it stops off. So maybe there's, I don't know, they just stopped paying people or there was no more payroll after that. But it looks like only for half of the month of July, we see a decrease. Then we just see nothing. So overall, we would say that June, the entire month is decreasing. July has a decrease, but it looks like it tapers off here, right? We don't see any more data for the second half of the month. So C, June, is going to be the correct answer.
The next question says, the manager of an apartment complex ordered the air conditioners in the apartments to be replaced. The list shows how many years each air conditioner had been in service: 12.2, 13.7, 11.9, 13.4, 11.9, 12.3, 12.9, 11.8, 13.3, and 13.6. Okay, so the question itself says, what is the median number of years that an air conditioner had been in service? And there's multiple choice answers. So as always, I'd like you to pause the video, try this out, and this will be a test if you understand how to find the median, and if not, as always, we'll just go over it. Okay, so the first thing to note for any median question, a lot of people remember for some reason, I think it kind of sticks, like maybe you remember from high school or just you knew it, that the median is the middle number. And that is correct, but you have to take the numbers and first put them in order from smallest to largest. All right, and unfortunately, I didn't go through this question, so I don't know if they did it in this case, but sometimes the people that write the tests, they will calculate, hey, a person, they might just look at the data set and go right to the middle number and think that's the answer. And so sometimes they'll try to trip you up. So you want to remember, though, that you need to put the numbers in order from smallest to largest first. So I think I've done it right. It took a little while, but I typed it all out here for us, and pretty sure I did it right. It's hard to, this is kind of a weird question because they give us so many different numbers to keep track of here. But the next thing we want to do is consider that there's 10 numbers in this data set, right? And why does that matter? Well, it matters because we're not going to have a true middle number, right? There's an even number of numbers here. So we have to kind of find the two numbers in the middle, and we're going to take the average. So let me show you how to do it. So I would go like this. I would cross out a number from the front end, cross out a number from the back end, cross out a number here, cross out a number from this end, and I'm just going to keep going. And the crosses are just to help me because see, now we're left with just the two numbers in the middle here, okay? we're left with the two middle numbers here, which is exactly what we wanted to get at. So the crosses, that's just to help me, just keep moving in here until we get the two numbers in the middle, because without all these crosses, right, it can be, if you just look at this big wall of numbers, it can be kind of hard to identify which numbers were the two middle numbers. So that's why I just kind of approached it that way. But now what we do is we need to take the average of these two numbers. All right, and all that means is that we're going to add the two numbers up and we're going to divide by 2. All right, so again, what are the two things you have to, as I write this out here, what are the two things to remember for finding the median? The first thing and the most important thing is to always take your data set and you want to rewrite it so that all the numbers are in order from smallest to largest. And you have to do that or the question will be wrong. All right, and then the second thing to consider, if there's an even number of numbers in your data set, and if you take the time to count all these up, you go 1, 2, 3, you'll find that there's 10 numbers here, right? At least that's what I'm assuming here, because I just did this off the top of my head here. But you want to note that if there's an even number of numbers here, there's not going to be a true middle number, right? You have to find the two numbers in the middle, and that's what I did, and you want to add them up and divide by 2. So I do that in my calculator here, 12.3 plus 12.9, divide that by 2, and the answer I get is 12.6, which happens to be the correct answer. Now, if you already think you know how to find the mean and the mode and all of that, then go ahead and move on to the next question here. But let me just explain if you're not sure how to do it. I'm not going to actually take the time to calculate it here, have other videos where I've done that, but I just want you to understand here too, if you had to find the mean, what you would do is you would take all these numbers and you would add them all up and divide by 10, right? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. All right, there's 10 numbers in the data set. To find the mean, you add them all up and divide by 10. The mode is the most occurring number, so it looks to me like 11.9 is going to be your mode because as far as I can see, the only number that appears twice is 11.9. So 11.9 is the most occurring number. It occurs twice. Every other number occurs once, so that would be the mode. And the range, basically, to find the range, mean, median, mode, and range, you take the biggest number, which is 13.7, and you would take the smallest number, which is 11.8, and I'm not going to actually do the math, but you would just subtract them, and that's all you would do. Okay, so hopefully now you have an idea of how to do all mean, median, mode, and range questions. This is a pretty typical median question that you would get because there's a couple tricks to getting this right. So please make sure you understand this because this is not just important for math. This can also come up on science, can also come up on social studies. So please be sure that you understand how to do mean, median, mode, and range because there's a high chance you'll see this somewhere on your test.
So below, the red arrow is going to point to the second video in the series once I have it finished, so you'll be able to click on that and go watch that video. Now the blue arrow, it points to a random video that YouTube is going to suggest that YouTube thinks will be helpful for you, and it says I'm feeling lucky on top because that's YouTube recommending that video to you. Thank you so much for watching.